So last week we finished up everything with quadratics. You had your tests. I think it was last Tuesday because we had the short week, so y'all are on the same rotation again, Tuesday, Thursday. Thursday, for those of you who weren't here after the test, we just kind of went over like the test a little bit. Y'all got to correct some of the questions that y'all got wrong and everything. So that's pretty much what we did last week. I didn't want to start on Unit 3 going into like a long weekend because I want to make sure that everything stayed fresh in your mind, especially being what's coming up in the second lesson. So Unit 3, we're getting away from quadratics and we're going to be moving into polynomials. If y'all know anything about quadratics and polynomials, you would know that a quadratic equation is a type of polynomial. Most of the time it's written as a trinomial, ax squared plus bx plus c. In this unit, instead of solving for like a variable, like in the last one we solved for x a lot, or we factored out everything, in this unit, you're not solving for an individual number or a variable. You're solving by simplifying a polynomial down as far as it'll go. So instead of having numbers, you will have equations. You will have like long different types of polynomials. This lesson, lesson 1, is going to be going over how to add, subtract, and multiply. A lot of y'all either saw this in Algebra 1 or Algebra 2, so this should be something fairly familiar to most of y'all. Okay. So most of y'all have seen this before, either in Algebra 1 or Algebra 2. A few students have forgotten a little bit about it as I've gone through the day with it, but it's not like the most, not the most difficult lesson. A lot of the students I taught last year when I taught this said that the material itself wasn't necessarily difficult. It's just some of the questions get to be long. I used to quote all year last year with them. Sometimes a lot of math problems don't get harder, they just get longer. It's extremely prevalent when you multiply polynomials. Adding and subtracting are fairly simple, but multiplying the questions do get a little bit longer. So I went ahead and handed out all your notes. So what I'm going to do is I'm going to write the questions on the board and I will tell you how to go through them. So at the very top, you should see where at the very top it says lesson 1, adding and subtracting, multiplying polynomials. And it has 2 steps for you. This lesson is split up into 2 different parts. The first part is going to be adding and subtracting polynomials. The second half is going to be multiplying, which is the one that takes a little bit longer. When you add and subtract polynomials, you have to do 2 separate steps. One of them, and you may remember this term from algebra, it's called combining like terms. Does anybody remember what a like term is? Yes or no? Yes, ma'am. Yes.
They have the same like variable or exponent.
They have the same variable and exponent. Thank you very much. Like terms are terms inside a polynomial or polynomials, depending if you have one or more, that have the same variable and exponent. When they have the same variable and exponent, you can add or subtract the numbers that are in front of the variables. If they don't, you can't do anything with it. And then the second part, the second step is once you simplify down a polynomial, you have to write it in what's called standard form. If y'all, which I'm sure most of y'all have, y'all took Algebra 1 and 2 using the Springboard books, right? They would have called this descending order, meaning from the highest exponent to the lowest exponent. So if it's like 4x cubed, the next one would be like an x squared, an x, and then just a constant term. So basically it's just from the highest number to the lowest. So here's your first question. The first one is number 1. It is 3x squared plus 11x plus 4 plus negative 5x plus x squared minus 13. So this is number 1 in your notes. When you have a problem that is a adding polynomial problem, the polynomials are split into 2. One of them is inside this set of parentheses, and the second polynomial is in this set of parentheses. And in between both of them, you have an addition sign. All you have to do is identify what are the like terms in the 2 polynomials, and then add the numbers that are in front of them together. That's all you have to do for an adding polynomial. So the very first term of the problem, you read it from left to right, is 3x squared. What number in the entire rest of the problem has the same variable and exponent as 3x squared?
X squared.
Just x squared. The x squared is in the second polynomial. What I like to do whenever I'm trying to identify like pairs or like terms is I like to underline them. And I like to have as many underlines in them as like pairs they are. So, for example, the first dash that I'll make, the first underline, will go under the x squares. I like to do this so I can identify which ones are like pairs. That way that you don't lose track. It's very good to do this, especially once we get to the multiplying polynomial part. So it's really good to go ahead and establish having some way to keep track of what you're combining. So the first one is 3x squared and x squared. If I were to add them together, like this addition sign says in the middle, what would it turn into? 4x squared. There you go. What you do when you combine like terms is all you have to do is identify which terms have the same variable and exponent. Once you do that, you combine the front numbers. The front one on this one is 3, and this one doesn't have a number, so it's understood to be what? 1. If a variable doesn't have a number in front of it, it's understood to be 1. So 3 plus 1 will give you the 4, and the x squared stays the same. What's the next term in the problem?
11x.
And does it have a like term anywhere in the rest of the problem? What is it? The negative 5x. I will make, since that's the second common, the second set of like terms, I'm going to put a second underline underneath. Keep track of which ones I'm combining. So if I were to add 11x and negative 5x, what would I get?
Positive 6x.
Positive 6x. That's exactly right. Remember, all you do once you identify like terms, just add the numbers in front. 11 minus 5 gives you 6, or 11 plus negative 5 gives you 6, however you want to read it. And then the last ones, you have 4 and negative 13. They are considered like terms as well because numbers that don't have variables or exponents technically have the same variable and exponent. They don't have them. So you will actually combine normal, what's called constant terms, normal numbers, you will add them together. So 4 plus negative 13 will give you negative 9. And this is the answer to number 1. That's all adding polynomials is. It's just identify the like terms, add the numbers that are in front of them, and then that's it. The second step is to make sure it's in standard form, it's in descending order, and if you look at it, it is in order. It's the 2, the variable without an exponent, and then the constant term. This is the proper standard form. This is descending order from highest exponent to lowest exponent. So that's the answer number 1. So now that we went over it, I want all of y'all to go to number 2. I want y'all all to work individually by yourselves. Do it yourselves. Do the same thing I just showed you. Identify like terms, and then combine them by adding the numbers in the front. I'll give y'all about a minute or two. It shouldn't take too long. I should give you just time to finish this one, and then y'all can go after that. Okay, so this question very similar to the last one. I mean, the only difference is they added one extra term to the very first polynomial. Other than that, the question is pretty much exactly the same. First thing you gotta do is identify the like terms. So we'll read it from left to right. The very first term in the problem is the 9n cubed. Is there a like term at all in the rest of the problem? Yes or no?
No.
No. If they do not have a like term, all you do is just basically drop it down. You don't do anything with it. If there's nothing that you can add to it, don't just make up something to add to it. Don't add it to something else. Just drop it down. It stays the same. The 9n cubed will be in your final answer. Next one is negative 4n. What would be the like term with it in the rest of the problem?
Negative 2n squared.
The negative 2n squared. If you were to add them together, you would add the negative 4 plus the negative 2, which would give you negative 6. And the back stays the same. N squared stays the same. Next one will be the 2n plus the n, because that's the next set of like pairs, the like terms, and they will give you 3n. And then negative 10 plus 7 will give you negative 3. Make sure it's in standard form, which it is. That'd be it. Yes, ma'am. Yes. So I had a student in my last class ask me about this. You can simplify it one more step, but we'll worry about it in a couple lessons because we're going to do a factoring polynomials lesson in like 3 or 4 lessons. So don't worry about this right now. You can. Do you know what the other simplification is? Yeah, you're going to factor out the GCF, which is 3. A student in my last class also brought this up to me, but I just told him don't worry about it. We'll worry about that whenever we get to the factoring lesson. But yes, you can actually do it one step. So unless you did the factoring step, if you did, that's good. If you didn't, this should have been your final answer. Make sure it's in standard form, which it is, and that'll be fine. All right. So for those of you who have to leave, I know that some of y'all have to go for the freshman pep rally. Y'all can go ahead and leave now. I know you have to be 11. So I'll let you go ahead. Wait, oh, we got one. While they're getting ready, I'm going to go ahead and write the next one. So now that's all you have to do for adding polynomials. Not a whole lot. You identify like terms and you add the numbers in the front of it. The next thing we're going to go over is subtracting polynomials. In all honesty, it's really no different than adding polynomials. It's just one extra little tiny step at the very beginning. So here's number 3. You'll have 5k cubed minus 2k squared plus 2k minus 2k squared. Y'all have regular skills there. Plus 2k plus 17. So this is number 3 that we're on. As you can tell, there's one key difference between this problem and the last problem. Instead of having the addition sign in the middle of it, you now have a subtraction sign. There is one thing you do whenever you have a subtraction symbol instead of addition. It's the only other step you add to the whole thing. You distribute the negative to every single term in the second polynomial. You will distribute this negative backwards. You will distribute it to the 2k squared. You will distribute it to the 2k, and you will distribute it to the 17th. When you do this, all you do is flip the signs of everything you distributed it to. The entire first polynomial, the 5k cubed, the negative 2k to the second, and the 2k all stay the same. You don't do anything to the front polynomial. It stays exactly the same. The negative will now turn to a positive in the middle of the 2 polynomials. And since you distributed the negative to everything in the second polynomial, everything will now either become a negative if it was a positive, or a positive if it was a negative. At first, it was a positive 2k, so now it will be a negative 2k squared. Then it was a positive 2k, then it turns into a negative 2k. And then a positive 17 turns into a negative 17. And now, it's just like every other problem that you just did. The first two problems we did, it's exactly the same as those now. You identify like terms, and you just combine them, and then put it in the standard form. First term in the problem is 5k cubed. Is there a like term anywhere in the problem? Yes or no?
-2.
Wait, what?
A like term,
Is there any like term with 5k cubed?
-2k. Wait, no, that's right, never mind.
Oh yeah, that's okay.
Sorry.
No. There is no other like term, like most of y'all should y'all said no. There is no like term with 5k cubed, so like I said earlier, it will drop down to the final answer. Next one is negative 2k squared. Is there a like term with negative 2k squared on this side, all the way to the right? What is it? It's the negative 2k squared in the second polynomial. So, underline both of those, and to add them together, it will give you a, that's it, a negative 4k squared. You add the numbers in the front, negative 2 plus negative 2 gives you negative 4. And then you have a positive 2k and a negative. You have a positive 2k and a negative 2k as your next set of like terms. Out of curiosity, when you add these two together, what happens?
They cancel out.
They cancel out because if you add the positive 2 and the negative 2 from this term and this term, 2 minus 2 or 2 plus negative 2 turns into a 0. 0k turns into a 0 because anything multiplied by 0 is 0. So they basically just cancel out. They don't do anything. And then the last thing is the negative 17 at the end. Nothing is a like term with it. So it just drops down. And this should have been your answer for number 3. So, like I said, subtracting polynomials is pretty much the same thing as adding polynomials. Only difference is you distribute the negative. So only real difference between this this material and what I literally just taught you. So adding and subtracting are basically two pieces of the same pie. They're basically the same thing. Subtracting is just one little tiny step at the beginning. Other than that, it's pretty much the same exact thing. So now for number 4, just like I asked y'all to do in number 2, y'all go ahead and work it out for by yourself. I will call on y'all randomly to help you with the steps through it whenever y'all finish with it. Okay. So let's go ahead, let's go over number 4. Okay. So, Mason, tell me, what's the very first step that I'm going to do to be able to simplify these two polynomials? What's the first step? Cancel out the lots.
Yeah, like you should not sure, like jump the line through.
Mr. Walker. Abby, tell me, what's the very first step that you're going to do in order to simplify these two polynomials? Distribute the negative to the second part of the problem. That's exactly right. You subtract polynomials. First thing you want to do is distribute this negative to everything inside the second polynomial. When this happens, everything in the second polynomial basically flips sides. If it's a positive, it's now a negative. If it's a negative, it's now a positive. The very first polynomial is going to be y plus 4y to the second minus 3 because nothing happens to it. The second one, the negative now becomes a positive. So the negative you distributed now becomes an addition problem. And everything flips sides. The negative turns the positive 1 to a negative 1 now. And the negative turns the positive 2y to a negative 2y to the second now. Same thing, negative 5y now becomes positive 5y, and negative y cubed turns into a positive y cubed. And from there, you identify like terms and add them together. So let's look, the very first one is a y. Miss Nola, tell me, what's going to be the like term with the y in the first polynomial? 5y. I just underline both of them, identify their like terms, and you add them together, what do I get? 6y. Absolutely correct. The next one is 4y to the second. Taurus, tell me, what's the like term with 4y to the second? This is the term we're on. 4y to the second, what's its like term? Talking about this right here, 2y to the second? Yes. The 4y to the second is going to be like terms with the negative 2y to the second. When you add them together, the 4 and the negative 2, what do you get? Think of it. See how it's 4y to the second? Yes, you're just subtracting. So yeah, it'll be just be 2. It'll be a positive 2, like you said, y to the second, because everything stays the same. Next one is a negative 3. Brooklyn, tell me, what's going to be the like term with the negative 3? The negative 1 in the second one. Yes, right here. And when you add them together, what do you get? Negative 4. Awesome. The last term is the y cubed. There is no y cubed anywhere else in the problem, so you know that it just drops down. It doesn't have anything to add with, you just don't add anything at all. Now, as you can tell, just by looking at the answers from the other 3 problems compared to this one, there's a distinct difference. Everything is out of order. You put everything from descending order of exponents from highest to lowest. What's the highest exponent in this problem? Like you said, the 3. The y to the third is the highest exponent, so it will automatically go to the front. The next one is going to be the 2. The 2y to the second. It will go in the second spot. The third one is the 1. It is the 6y. It is going to be the one with just the variable. So the positive 6y will be third. And then the last one will be the last one left. It'd be the negative 4. And this should be the answer that you've got for number 4. This is how you distribute the negative. This is how you add by combining like terms, and then just sort it out. This is about as difficult as a subtraction polynomial problem will get. All you have to do is identify like terms and simplify. Yes, ma'am. On 5? I was actually going to skip 5 just because. So what was your question on it? All the same.
So what? If there was, if I have a variable that's 9a squared plus 9
Mhm.
would that be right? Because they-
Yes, because their totals will add up to 2, and you always put multiple variables in front of single variables, yes. That is exactly right. So, now, we're gonna kind of move away from adding and subtracting polynomials, and we're gonna go to the second half of the lesson. We're gonna go to the multiplying polynomials part. It's on the back of the very front page. Multiplying polynomials do typically have a little bit more to do than normal adding and subtracting. Adding and subtracting really, in all honesty, isn't bad because all you're doing is adding the numbers in the front. The hardest part is just identifying which numbers to add. Multiplying, you do have to do a little bit more work for them, but they're pretty okay. I used the saying for the last class I taught that problems in math a lot of times don't get more difficult. A lot of times they just get longer, which in turn people tend to think that makes them more difficult because it gives you a lot more opportunity to make mistakes. It's a whole lot easier to multiply 2 things rather than multiply 16 things because it's very easy to miss something by accident. If you're going at the first, you may be trying to be very meticulous and try to get every single thing right, but as time goes on, you start to care less and less, or you start to try to feel like you're in a rhythm more and more. And when you do that, you tend to get more problems. So with multiplying polynomials, I'm going to emphasize to please take your time. It is very easy to slip up on one little tiny thing that'll mess the whole problem up. I saw it a bunch. I saw kids that knew what they were doing and would just miss one tiny thing and mess the whole problem up. So please, on this next part, take your time. Make sure that you aren't trying to speed through it. So if you look at it on your notes, it has pretty much the same 3 steps next to multiplying polynomials, except for they added one at the very beginning. It's called distribute or FOIL. Has anyone ever heard of the acronym FOIL before? Does anybody remember what it is?
First, outer, inner, last.
That's it. I mean, you can switch the names up a little bit. Some people say front, some people say a few other things, but typically it means first, outer, inner, last. It stands for the multiplication steps that you do when you multiply 2 binomials. It is directly correlated to what's called the distributive property. Y'all should have learned this back probably in about 7th or 8th grade. The distributive property is when you multiply things that are on the outside of parentheses, inside of parentheses. So here's your very first problem with multiplying polynomials. So make sure you pay attention so you can see all the steps. Number 6 on your paper says w minus 7 times w squared plus 2w plus 1. When you multiply polynomials, the reason like I made the point about how it got long is that you are going to multiply each term or every term in the first polynomial, which is w minus 7, by everything in the second polynomial. So the first term in this problem is w. You will multiply w times w squared, 2w, and 1. And once you're done with that, then you go down the list. You go down to the next polynomial. You will multiply -7 by w squared, -7 by 2w, and -7 by 1. So when you do this, you will actually get 6 different terms in your final answer, and then you have to simplify it down from there. So here's how you multiply polynomials. You multiply each term. The very first multiplication is going to be the w times the w squared. Does anybody remember back from algebra 1 and 2, what will you end up getting?
WQ.
You will get w cubed. In case some of you have forgotten, like why it is or how it is w cubed, here is the answer. When you multiply, let me write it here, w times w squared, you're technically doing two separate multiplications in this. You're multiplying the numbers that are in front of the variables, and you're also multiplying the variables with the exponents. The first part's easy. What's the two numbers in front of the variables? What are they understood to be? 1. So it's 1 times 1. If you're multiplying the numbers in the front, it's 1 times 1, which will give you 1. Then you multiply the variable part. When you multiply variables with exponents, does anybody remember what do you do with the exponents?
Add them.
You add them. It's one of the very first things you learn in about 8th grade math. You learn the exponent rules. When you multiply variables with exponents, you add exponents. Whenever a variable does not have an exponent, it's understood to be 1. So when you multiply w times w to the second, it turns into w cubed. And that is how you got that. That's what we're doing, please. All right. So that's how you multiply terms of variables. It turns into w cubed. So now, all that being said, what's w times 2w turn into? 2w squared. And then the last one is w times 1. What does it turn into? Just w. Yes, absolutely correct. That's it for the first term. Now you do the -7. You do the second term in the problem. -7 times w squared turns into what?
-7w.
There you go. -7w squared. Then -7 times 2w turns into what?
-14w.
And then the last one should be the easiest one. -7 times 1 is what? -7. Yes. So here's where the point where I made about everything being longer comes into effect. Now you have to simplify the answer that you got. You did all the multiplications, you end up getting this. Now, all you're doing is the same thing we did in the first 4 problems. You're combining like terms. Identify what are like terms in this long little problem, add them together, and that'll give you your answer. Do the same thing we did earlier. Magdalena. Very first term is w cubed. What is the like term within the rest of the problem, or is there one? There isn't. It'll drop down. It'll be w cubed. Next term is 2w to the second. What's the like term with it in this problem?
-7w.
Absolutely. -7w squared. When you add them together, it will give you -5w squared. Because 2 plus -7 gives you -5. The next one is the w. What's its like term? -14w. And when you add them together, it turns into -13w. And the last one, -7. And since it doesn't have a like term, it drops down. And that would be your answer. That is how you multiply polynomials. Okay. Okay, what I want y'all to do is I want y'all to go to the second page I should have given y'all, and I want y'all to do number 9 and number 11. I'm gonna leave this up on the board so that you have something to look at. But do number 9 and number 11. Just to kind of give y'all a little bit of a hint for number 9. It's this right here. It's 2c plus 5b cubed. What do you think that means then if it's cubed?
4 3 times.
It's the same thing 3 times over, so you should rewrite it like this: 2c plus 5b 2c plus 5d, and then 2c plus 5d. You have to do the same multiplication 3 times. So I'm gonna let y'all do number 9 and 11, and if y'all have any questions, I'll walk around and help y'all. And I'll, yes, you